Welcome, everyone. I will be talking about whether and if so, how we can learn from existing complex systems, about risks from advanced artificial intelligence and AI alignment. So what is the motivation of this? Well, at the start, we have the problem of how we can align advanced artificial intelligence systems. I won't go too much into depth on this. I imagine most people are familiar with the basic idea for why this is important. Now, when we talk about aligning AI, one thing that is interesting to notice is that I think we face a particular epistemic challenge that is quite interesting to think about. In particular, we are trying to study a system that doesn't actually quite exist yet, and on which we also can't iterate as we can iterate on other sort of engineering problems that we face. So we can't sort of use exactly the same sort of scientific or engineering epistemic strategies as we do on many other problems that we are interested in. And then the question is, well, given that challenge, what are the epistemic strategies that are available to us? I suggest there's roughly three that are currently being used. The first, I'll call it something like tinkering. Well, the idea here is that we can look at existing ML or AI systems and sort of use those systems via trial and error, via experimentation on those systems to explore kind of the close end of the plausibility space of what complex behavior can look like and what it currently looks like in these systems. And we sort of explore the frontier of these complex behaviors there. Sort of it's one sort of empiricism. Another way we can look at and try to understand the possibility space of complex behavior is by using idealized conception of what complex or intelligent behavior is like. So here we sort of look at behaviors at the limit. Sort of we presuppose sort of perfect rationality, or like we presuppose some premises that we use in formal epistemology or decision theory, for example, to try to understand some principles of how complex behavior or intelligent behavior works, or what it should look like, and extrapolate from there. And then a third way, and this is the one I'll talk about more in this talk, is that we could also instead look at how intelligent or complex behavior is implemented in current systems, be that biological or social systems, and sort of look at those naturally occurring phenomena and see whether there's analogies, disanalogies, parallels that we can draw that thereby then can help us learn about this possibility space better. And I'm sort of suggesting that this might be, in a way, the most natural or sort of realistic approach of thinking about intelligence, because we do have examples in the real world of what intelligence does look like and how it is implemented. And it allows us to have some sort of empirical grounding in existing mechanisms while also exploring a wider possibility space, as if we only look at current ML systems. So having sort of introduced the main gist of this epistemic bet, which sort of I summarize here as studying the parallels between intelligent behavior in how it's currently manifesting in currently existing biological or social systems, and using that to inform the design of future and artificial systems that exhibit such intelligent behavior or specific properties we might want from such systems. And just a few examples here of what fields we might be able to draw on to inform this strategy. This might include ecology, evolutionary biology, but as well as cognitive sciences, neuroscience, sociology, legal theory, political economy, linguistics, media studies, philosophy of science. I'm sort of suggesting that areas within these fields all are looking at examples of intelligent behavior or related phenomena that might be interesting for us. And the underlying intuition for why this might actually be interesting and might work is that we might assume that there is sort of a wide variety of complex and intelligent systems that exhibit similar phenomena, phenomena which are also interesting from the perspective of AI alignment, and third, which are governed by principles that are like valid across these modalities of implementation. And if that is the case, we can sort of then assume that we can maybe learn something about how intelligent behavior is manifested or specific properties from these systems. Now, substantiating this a little bit more, I want to give you a few examples of what this could look like. So here's a table where we have different systems, biological ones, economic systems, markets, RL agents, sort of typical ML systems that we're using these days, and how we can see different phenomena sort of analogize between these systems. So what do goals look like in these systems? What are the learning mechanisms that these systems exploit? And then we could be asking, okay, where do these analogies hold? Where are the limits of these analogies? And then below the table, you see some more examples of other phenomena that we might be interested in: corrigibility, robustness, agency, multi-agency, modularity, things like this. So together with some of my colleagues, we have been thinking about this for some time and have sort of like created some sort of research map clustering together things that we found interesting. This is an overview. I won't have time to go in depth on these topics, but happy to chat more to people who are interested in this. Just to give you a very quick sense, the first two examples draw a bunch on the cognitive sciences, neurosciences, sort of using minds in human minds and to some extent non-human animals as existence proof of intelligent behavior, and what we can learn from these. Then we have mechanism of knowledge and normativity. So here it's sort of thinking about how, cool. So I'm running basically out of time. I'm going to just zoom out on the last slide, zooming out a bit what domain ambitions are here. So this is just providing conceptual affordances to progress current research strategies, but also fostering a diversity of viewpoints and competencies in the alignment research community, and then maturing maybe what could become a research agenda within this third epistemic approach. Here are contact information if you're interested in chatting about this more. We are currently running a fellowship to experiment with this approach. Thanks very much.